Hi guys, we're going to do one sample t-test from you. Let's get going. A bottle filling machine is set to dispense 12.1 fluid ounces into juice bottles. To ensure that the machine is filling accurately, every hour a worker randomly selects 4 bottles filled by the machine during the past hour and measures the contents. If there is convincing evidence that the mean amount of juice dispensed is different from 12.1, or if there's convincing evidence that the standard deviation is greater than 0.05, the machine is shut down for recalibration. It can be assumed that the amount of juice that is dispensed into the bottles is normally distributed. That's awesome because that means our normal condition is checked. Okay, during 1 hour, the mean number of fluid ounces of 4 randomly selected bottles was 12.05. We know right away that this is an X bar. How do I know that? Because this 12.05 right here, that's describing this 4 randomly selected bottles. With the standard deviation of 0.085, that's an SX. That is not a sigma, because that again is describing the 4 randomly selected bottles. Okay, A, perform a test of significance to determine whether the mean amount of juice dispensed is different from 12.1 ounces. Assume the conditions for inference are met. I do have these underlined. I'll tell you why here in a second. We're going to go right to part A, and then we'll go to part B on the next slide. So we're doing a state, a plan, a do, and a conclude. In the state, just a friendly reminder, what do I need? I need a mu, I need a null hypothesis, and an alternative hypothesis, as well as an alpha, a significance level. If you read through this again, they do not give this to us. So we assume that that significance level is 0.05. Our mu, that's describing the population. What is that parameter of interest? What do we care about right now? Look, the question will tell you. We care about the true mean amount of juice dispensed, okay? And so mu, or mu as a symbol, is the true mean always, and then fill in the blank. Use the College Board's question to help you. They'll help you out, okay? HO, what is mu equal to? Well, some people struggle with what is mu equal to. What is that parameter describing the entire population, okay? Some people don't know that. So go to the question. What are we trying to figure out? What is the alternative hypothesis? We're trying to find out if that mu is different than 12.1. So that's right there. And then what we know is that these have to match, right? Okay, so then mu is equal to 12.1. And then finally, we need our alpha. Alpha is equal to 0.05. State, done. Mu, null, alternative, alpha. Okay, next, our plan. Our plan are our conditions. We're going for a RIN, okay? And then we need a method. I talked about the RIN, what you need in yesterday's notes. Please look at that. I am not going to talk about RIN today. You know why? Because we're jumping for joy. The problem says the conditions are met. The catch is, though, is we have to actually state that. The conditions are stated as met. And I did give you a little friendly reminder of what I talked about with that normal condition. And in yesterday's video, I also talked about if it's an experiment and not an observational study, what you need to do. So make sure that you check that video out from yesterday. That was the one sample T interval for mu. That was the video from yesterday. We have to still state that conditions are stated as met, and we still need that method. How many samples? 1. Is it a T or a Z? It's a T. How do I know it's a T? We're dealing with means, not proportions. It is a test for mu. Plan, check, we're done. We're cruising here, you guys. So if you have any questions, pause, write them down, message me. Let me know if I'm going too fast. This is not meant to teach you from scratch. This is meant to review with you, okay? If I was teaching you from scratch, I would slow it down, but it's meant to review with you. We're on to the do. Ultimately, what is the College Board looking for the do? All they are looking for, you guys, I'm going to actually delete this. All they're looking for is that t-score, your degrees of freedom, and your p-value. But I know a lot of you want that insurance policy, and you actually like drawing that curve. So I have it all filled out right here, okay? We draw that curve, and we need our degrees of freedom describing that variation. That degrees of freedom is your sample size minus 1, and our sample size is 4, so 4 minus 1 is 3. Our standard deviation, I'm not going to take the time right now because I know you guys are crammed for time with AP tests right now. You go to your formula sheet. If you watch my videos, you know my favorite page and how to get there. You take that sample standard deviation that gave you 0.085, that's up in the problem up here, okay? And you divide it by the square root of the sample size, that's 4, okay? Where does this mu come from? This one right here, this is our parameter, always, our null hypothesis. Mu is equal to 12.1. A common mistake, people will put p there sometimes, or they'll put x bar. It's a parameter, okay? The true mean that we know right now is 12.1, okay? So then what's next? We need a statistic. And that statistic right there is going to be our x bar. Where does that come from? That comes from up here, okay? When they talked about what is describing the sample, a statistic describes the sample. So that's that 12.05. Whoops, sorry guys, I went too far. And then why did I shade this other side over here? I didn't do the best job of shading. It really should be similar area, but it doesn't matter that much, okay? I shaded this area because it's a two-sided test. What do I mean by that? My alternative is a not equal to. I have my curve all set up, and now I go to my toms, not my zums, my toms. T is equal to what I observed minus my mean divided by my standard deviation. So I have that work right here. And I get negative 1.176. And I'm going to become 1 with my calculator. So I go to my calculator, which is right here. And I go to stats. And I arrow over to tests. And I apologize right now if you can hear my children. I go to t-test. I do not have data. Data is if they would give you a list of data. You have to put it in L1 first, and I've described how to do that in previous videos. If you have questions, really comment, message me. I'll get back to you, okay? But I have statistics. They have given me an X bar, and they've given me an SX. I hit enter. This right here is my mu, okay? This is my null hypothesis, my 12.1. Here I have X bar, what I observed, okay? What describes that sample of 4. And then my standard deviation, what describes that sample of 4. Right here's my alternative, and I follow the sign just as is. I have a not equal to. And I go down and I calculate. So you can see I have my t-score right here. And then over here, I wrote that p-value down. And I'm really good to go from there. The issue is, though, is some of you don't have a graphing calculator. So what's going to happen if you don't have a graphing calculator for this test is you're very paying attention to details. That makes all the difference. You're plugging in what I observed minus my mean, hit enter, divide by my standard deviation, and I should get this number. Then I'm going to go to table B. Table B is right here. I'm going to go to degrees of freedom of 3. I'm going to take the absolute value of my t-score, which would be 1.17, I believe. Let me just double check because I don't always have the best memory when it comes to that. Yeah. Okay. Okay, so degrees of freedom of 3, I scroll over and I see, hey, 1.17 is in between 0.978 here and 1.250. So I scroll up, which means my p-value is between 0.15 and 0.20. Again, degrees of freedom is 3. 1.17 is between 0.978 and 1.250. I'm in this little row right here, or column. I scroll up. My p-value is between 0.15 and 0.20. So what I do is I mark that right here. Here's the catch, though. Oh, shoot, my cursor just dropped. Give me a second. The catch is that the p-value from the calculator does not fit that. Why? And the answer is because it's two-sided, a not equal. Whenever you don't use your technology from a graphing calculator and you do it by hand, whenever it's a not equal to, you have to multiply that p-value by 2, which means if I take 0.15 times 2, that gives me 0.30 is less than my p-value, which is less than 0.4. And that makes sense, you guys. My actual p-value is in between that, okay? So our p-value is very high. So in this case, when your p-value is low, you reject the HO. Our p-value is not low, so we fail to reject the HO. Because our p-value is, you're going to fill that in. Is it greater than or is it less than? In this case, it's greater than alpha. We fail to reject or reject. In this case, we fail to because it's greater, the HO. We have no evidence, so you'll either have evidence or no evidence, that the true mean, fill in, this is HA in context. HA in context is the true mean amount of juice dispensed is not equal to 12.1. Deep breath. Okay, now what we're going to do is we're going to quickly talk about part B, because I really think that's a good way to just review simulation and just kind of an extension on what they may test you on. I'm not confident they will do that this year in 2020. This is kind of pushing it out just a little bit. Not that much, just a little bit. But I still think it is pretty important to review. So let's quickly look at part B. Okay, so in part B, it says, to determine whether the sample of the 4 bottles provides convincing evidence that the standard deviation of the amount of juice dispensed is greater than 0.05, a simulation study was performed. In the simulation study, 300 samples, each of sample size 4, were randomly generated from a normal population with a mean of 12.1 and a standard deviation of 0.05. The sample standard deviation was computed for each of the 300 samples. The top dot plot below displays the values of the sample standard deviations. So each one of these dots represents an SX for that sample size of 4. Use the results of this simulation study to explain why you think the sample provides or does not provide evidence that the standard deviation of the juice dispensed exceeds 0.05 fluid ounces. Let's dissect this. We're going to use this right here instead of like a Tom's, okay? We want to have evidence or no evidence that the juice dispensed exceeds 0.05. So let's start with this part right here. The standard deviation of the juice dispensed exceeds 0.05. That's what we're trying to find evidence for. And that's why I have sigma, which represents the standard deviation, is greater than 0.05. I'm trying to find evidence for that, which means my null hypothesis has to mean sigma is equal to 0.05. What is sigma? The true standard deviation of the juice dispensed, okay? Next, what are we going to do? Okay, well, we don't have conditions that we need to do because we haven't learned that for sigma, right? This is we're just using a simulation here. And it talks about the sample. What do they mean by the sample? Does our sample provide evidence? Here is our sample up here. So here is our statistic that we care about, because we need to generate a p-value right now, you guys. We need to generate a p-value. We know, so if you didn't know that, you're like, wait, how was I supposed to know that? Dissect and you say, okay, we have a sample right now. I'm dealing with some standard deviations, and I had an SX of 0.085, which is approximately right here. Well, not many happened above that. And when we have a simulation, we're trying to find a probability based off that simulation. That's what we learn when we're doing simulations. And now this is tied to what we've been doing with significance testing. So we have a statistic, and what is a p-value? Well, a p-value is the probability of getting a statistic as extreme or more extreme than what we calculated, given the null hypothesis is true, the 0.05. Well, we're not going to find a t-score, a z-score, but we're going to use this simulation. We're going to say, well, out of these 300 samples, okay, of size 4, so each one of these dots represents size 4, and they're all sample standard deviations, we're going to count how many were above this sample right here. More extreme. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? 12 out of the 300 were more extreme than what we calculated. And that gives us a p-value, you guys, of 0.04. So what did the College Board said? They said in 300 simulated sample standard deviations, the value of the computed standard deviation from our sample in part A, or larger than that, occurred 12 times. This is a simulated p-value of 0.04. Okay, I'm going to go down to the next one here, okay? Because they just said the second sentence is just redundant, in my opinion. Because the simulated p-value is less than the significance level of 5%, 0.05. Okay, the sample, right here, this sample, right, provides strong evidence that the standard deviation of the juice being dispensed exceeds 0.05. In other words, because our p-value is less than alpha, we reject the null hypothesis. And we have evidence for the alternative hypothesis that the true standard deviation of the juice being dispensed is greater than 0.05. That part was a review. I went quick. I'm sorry. I'm just trying to get these done for you guys. It's been a long haul, I know, for all of us, but you guys are doing amazing. And I'm going to keep being your cheerleader, your biggest cheerleader yet. So keep it up. Stay strong. Stay healthy. Keep learning. You guys are doing amazing. I miss you guys a ton. And good luck with all your AP exams tomorrow. So take care.